In this lesson, we're going to be talking about linear and absolute value inequalities. If you haven't done so already, please be sure to read through the section 1.7 linear inequality document so you can get an overview of interval notation as well as the full steps for how to solve a linear inequality. This example that we have right here is going to be a unique situation. So right now we have 3 times the quantity of x plus 1 is greater than 3x plus 2. Anytime I'm solving a linear inequality, essentially you want to follow your steps for solving a linear equation. But remember, if we at any point need to multiply or divide by a negative number, we have to flip the inequality around facing the other direction. So it's kind of your brief overview of solving a linear inequality. Which means for our problem then, I'm just going to start by distributing the 3. So I have 3x plus 3 is greater than 3x plus 2. So solving for x, I'll move my 3x from the right side over to the left, so I'd be subtracting 3x from both sides. And when I do that, we can see that our 3x's actually cancel out, and what we're left with is just 3 is greater than 2. So when our x's cancel out, then we have to think about what happened when we had our linear equations and our x's canceled out. We had 2 unique situations based off of the statement that we were left with, and this is going to be true for linear inequalities as well. So if our x's cancel out, we look at the resulting statement. If the resulting statement is true, then the solution would be all real numbers, or negative infinity to positive infinity when we write it in interval notation. If the resulting statement that we have is false, then there's no solution, or we would have the empty set. So looking at what we have the statement 3 is greater than 2. Well, I think that's a true statement. I think that 3 is greater than 2, which means that our answer would be an interval notation, negative infinity to positive infinity. And then if we're drawing a number line, if I put 0, you can put a few other numbers on there if you want. But really our answer then, since it's all real numbers, would just be the entire number line. So what I put in blue here shows our solution graphed on a number line. And then that will be it. So next we're going to be dealing with solving absolute value inequalities. When we're dealing with absolute value inequalities, our first step is that we want to try to simplify the inside of your absolute value first. So here I'm going to do that by first distributing the 3. So I'd be left with the absolute value of 3x minus 3 plus 2 minus 3 is less than 20. I can continue to simplify the inside by combining like terms, so we have the absolute value of 3x minus 1 minus 3 is less than 20. After we do that, our next step would be to isolate the absolute value just like we would do if we had an absolute value equation. So I'm going to move that 3 over, so we're left with the absolute value of 3x minus 1 is less than 23. Our next step is to solve this inequality. If you remember back to when we were doing the absolute value equations, we said that we had to set up 2 equations if we had an absolute value equal to a positive number. In this case, when we're dealing with an inequality, we have an absolute value that's going to be less than or greater than a number, and we have 2 different situations in order to set this up. If we have the absolute value is less than a number a, then we want to set up a compound inequality of the form negative a is less than x, which is less than a. Essentially, you want to think of it as setting up one long inequality. So if the absolute value of x is less than a, and also less than or equal to, so less than or equal to would be interchangeable. You're going to set up one long compound inequality. Negative a is less than x, which is less than a. If the absolute value of x is greater than a, or greater than or equal to a, then we set up a compound inequality of the form x is greater than a, or x is less than negative a. Essentially, you're going to be making 2 separate inequalities. So in this case right now, we have the absolute value of 3x minus 1 is less than 23. So since we have a less than, that means we're going to set up one long inequality, compound inequality, of the form negative a is less than x, which is less than a. Well, that a is just our number. So I'm going to rewrite the inside of the inequality, or excuse me, the inside of the absolute value, which would be 3x minus 1. Keep the less than 23. So essentially you're rewriting what you already have. But then I'm going to bring everything over. I'm bringing over the less than is coming to the other side. And then that 23 is going to come over as a negative 23. So we're keeping the same number but changing the sign, and then the inequality symbol is staying a less than. At this point, then, we can solve for x. So in order to solve for x, I need to get x by itself by moving the 1 over. So when I move the 1 over, I would be adding 1. And when I add 1, I'm not just adding to the left and to the right. I have to also go way left over to the negative 23. So I'm really adding the 1 with the left, the middle, and the right in order for it to cancel out. So we would be left with then negative 22 is less than 3x, which is less than 24. And then finally I need to divide out that 3. And when I divide out the 3, that means that we're going to be left with an answer of negative 22 over 3, which is less than x, which is less than 8. So we want to be able to write this in interval notation as well as graph it. Writing it in interval notation isn't too bad because we just have a less than and a less than, and our x is in the middle. So what this reads is that negative 22 over 3 is less than x, which is less than 8. Or we want all of the values that are between negative 22 over 3 and 8. So we use parentheses with both since we have less thans, negative 22 over 3, all the way up to 8. So there's no infinities. That would be your interval notation. If we're trying to graph it on a number line, we would have 0. And then somewhere down to the left, we would have negative 22 over 3. On the right, we would have an 8. Again, keep those same parentheses. And then it will be connecting in the middle. We want all of the values that are between negative 22 over 3 and 8. So that would be your interval notation answer, and then you're graphing it on a number line solution. So one last problem dealing with absolute value inequalities. Here we have the absolute value of 2x plus 2 over 4 is greater than or equal to 2. So our first step would be to try to simplify the inside. So the only way that I could try to simplify this would be to factor out a 2. So if I factored out a 2, I would be left with the absolute value of 2 times x plus 1 all over 4 is greater than or equal to 2. And then I can reduce the 2 and the 4, so that way we're left with an absolute value of x plus 1 all over 2 is greater than or equal to 2. Our next step would be to isolate the absolute value. In this case, the absolute value is by itself, so we can move on to our third step. So we're left with the absolute value of x plus 1 over 2 is greater than or equal to 2. So from here, we need to go back to those rules that we had before. We now have an absolute value that's greater than or equal to 2, which means we're going to make two separate inequalities to form a compound inequality of the form. Essentially, we're just going to be keeping what we see without the absolute value bars. So you're going to have x plus 1 over 2 is greater than or equal to 2, or x plus 1 over 2, flip the inequality, so less than or equal to, and then we're going to make the 2 a negative 2. So that idea that when we multiply and divide by a negative, we flip the inequality, same thing here, is that when we're making that number negative, we have to flip the inequality. Now it's a matter of solving for x in each case. So I'll start on the left-hand side. We need to get rid of that fraction, so I'm going to times both sides by 2. So that way we would have, these would cancel out, you're just left with x plus 1 is greater than or equal to 4. We do not flip the inequality because since we multiply by a positive 2. Continuing to solve for x, we would have x is greater than or equal to 3. Then on the right hand side, we would have, again, multiplying both sides by 2. Still not flipping the inequality around, so we're left with x plus 1 is less than or equal to negative 4. So when we solve this, then we're going to have x is less than or equal to negative 5. So we do have two pieces. My suggestion is to actually graph it on a number line first. That way you can visualize what each inequality means. So we have our 0, we're going to have a negative 5, and then a 3. So x is greater than or equal to 3 means that we want all the values that are larger than 3. Well, that means that I'm going to be going to the right of 3. Greater than or equal to means I'm going to be using a square bracket. For x is less than or equal to -5, that means I want all the numbers that are smaller than -5, so I'm going to be going to the left. And again, since it's less than or equal to, I'm going to be using that square bracket. So with that or, when we graph it, we can see that there is a space between both of our inequalities. So then writing this in interval notation, we would have, starting at the left, negative infinity to -5 with the square bracket, and instead of writing an or, we use the union square bracket of +3 to infinity.